Today we're going to do a walkthrough of the VBA code required for level 1 of Ranger Quest, the Elemental Orbs, and show how it is possible to have moving graphics in Microsoft Excel. We'll look at the graphical elements along with the macros controlling the orbs and how the activation of the shrines moves the walls of the maze. We will also look at how the Ranger moves and what prevents him from walking through the walls. I encourage everyone to watch the YouTube video Ranger Quest Level 1 Walkthrough first, as the code will be easier to understand if you have a good understanding of the gameplay. Let's get started by zooming in and taking a closer look at Ranger Quest. You'll notice that the current magnification of the game is set at 20%. Let's set that to 100% so we can take a good look at the graphics. Ranger Quest is built from 10 pixel by 10 pixel block elements. This block element is a wall section. The column width has been set to 1, and the row height has been set to 9. This creates these square cells that we will use as our pixels. Excel uses an alphanumeric system to describe cell locations. The cell in the top corner is A1, and the cell in the bottom right of our block element is J10. You can also think of these cell locations as an X and Y grid. The X coordinate will determine the column, while the Y coordinate will determine the row. The location of each block element will have an address based on its lower right corner. The first block will have an X coordinate of 10 and a Y coordinate of 10. The next block element will have an X coordinate of 20 and a Y coordinate of 10. This block element will have an X coordinate of 20 and a Y coordinate of 20. All the block elements in the game can be identified in this manner, and all of them will be a multiple of 10. It's just easy counting by tens. Now let's pan down and take a look at the Ranger. You'll notice that the Ranger is also a 10 by 10 block element. Let's have the Ranger walk one square to the right by using a copy and paste command. That is a little embarrassing. It looks like there's two Rangers. Let's copy and paste a pathway block to cover up the old Ranger. That looks right, and if we had done it faster, it would have looked like the Ranger was walking. We also can use the same copy and paste commands to move the walls of the maze, like so. Let's take a quick look at how to color the pixels that make up the Ranger. Select the cells that make up the Ranger's boots, go to the Home tab, you'll find the Fill Color drop-down box. As you go through the various color options, you'll notice that there's a vast quantity of colors to choose from. How about we make the Ranger have red boots? No, I don't like that at all. Let's set them back to black. That's much better. Now let's take a closer look at the coordinate system. For the game to work, the Ranger's starting location, last location, and current location must be known. This chart identifies the X and Y coordinate of the bottom right cell that makes up the Ranger block element. There is also a combined number that we can call the Ranger positioning system. The first 3 digits are the Y coordinate, 2 digits if Y is less than 100, and the last 3 digits are the X coordinate. This allows us to use a single number in our location arrays. You'll notice that there isn't any formulas in this table. Excel is widely used because of how easy it is to set up calculations. So let's calculate the Ranger's position using a formula. We'll add the Y coordinate to the X coordinate, and then multiply the Y coordinate by 1,000 because it is located in the thousands position. We can copy that formula, and now we have the starting, current, and last location of the Ranger, and it matches the table values. However, in Ranger Quest, the VBA macros will read and write data from the cells and complete all of the calculations. Not having calculations completed by formulas in cells speeds up the game. So let's erase these formulas to make sure we are consistent. There are a few more important numbers here. This direction number tells us which way the ranger is facing. Up, right, down, or left corresponds with 1, 2, 3, or 4. Floor 1 identifies the starting layer when the nature shrines are deactivated, while floor 2 indicates we have activated the nature shrines. Related to floor numbers are these lists of numbers over here. These arrays identify every location of a wall on the corresponding floor level. The walls of the maze move, so a list of wall locations is required every time an elemental orb is activated. Only the nature orb is available on level 1, so we can only access 2 layers of the maze. When the 4 elemental orbs are available, the maze will have 5 layers, making the levels longer and more challenging. Activating the nature orb will take you from floor 1 to 2, the water orb will take you from 2 to 3, the fire orb from 3 to 4, and the wind orb from 4 to 5. As the walls of the maze are always moving, we will then require 5 different wall arrays that correspond to each floor of the maze. The numbers in these 2 cells will either be 0 or 1, and tell us if we have activated a shrine or recharged the nature orb. That should be enough background information, so now let's dive into the code within the VBA macros. Select the Developer tab, click on Macros. Blue Orb 1 is the macro for the water orb. Now we can see the code for level 1. The code for the water, fire, and wind orbs is very simple, as they are not used on level 1. The code is setting a text value to the cell location A222. Cell A222 is the location of the message box under the game screen. As we click on the 3 orbs, the corresponding messages will pop up. Let's walk through the code for the nature orb, which is macro green orb RQ1. So here we have an if statement. If this logical argument is true, then it will perform this statement. If the logical argument is false, then the else statement will be performed. The end if identifies the conclusion of the if statement. But what does all this mean? Using our ranger positioning system, we know where the locations of the 2 nature shrines are, at locations 100,080 and 130,330. Previously, we had been looking at the table showing the locations of the ranger using the ranger positioning system. The ranger's current location is shown in cell SA6. At shrine is a variable that will be set to 1 if the ranger is standing beside a shrine, or else 0 if the ranger is not. As we walk through the following if statements, I will translate what is happening instead of referencing cell locations and zeros and ones. If the nature orb is not recharged, show this text in the message box. Or, if the nature orb has been recharged, but we are not at a shrine, show this text in the message box. Or, if the nature shrine is deactivated and the nature orb has been recharged and we are at a shrine, then let's activate the nature shrine. Now we will be on floor 2 of the maze and we need to move the walls. Here is a series of copy and paste commands where we are taking images of various block elements from an image library, located elsewhere on the spreadsheet, and pasting them on the game screen. All the locations are described using Excel's default alphanumeric address system. This is where an image of the block element of an activated nature shrine is located. This is an image of a pathway, and this is an image of a wall. Here we are changing the color of the cells that form the border of the game screen. RGB 102, 255, 102 is a system of describing the red, green, and blue tint of a color. This color happens to be green. And finally, we have a text message pop up telling us we have activated a nature shrine. The last of the if statements is the process of deactivating the nature shrine, essentially the opposite of the activation process. Let's jump back to the game and watch the activation and deactivation of the nature shrines again. You can observe the messages changing the message box, the shrines turning on and off, along with the border changing color to identify what layer of the maze we are on. The walls of the maze are also moving and then returning to their starting location. The final nature orb if statement will be true if we are located at the exit of the maze. The macro restart RQ1 will be activated, then we will wait for 2 seconds before being taken to level 2. Let's open the code for the restart RQ1 macro. pressing the restart button or completing the level will activate this macro, which will reset the level to its default starting location. Just a quick note, the writing in green is not part of the computer code, but is comments to help with troubleshooting. The code for this macro is similar to the coding of the more important macros, so we're going to scroll down to see how the ranger walks. Here we have the up RQ1 macro, which activates when we press the up arrow button. We are now preparing to step one square up, so where we currently are is going to become where we were. Our new current position will be one block above where we were. In mathematical terms, we will subtract 10 from our y coordinate. We can observe this on the game screen, where cell SC6 is showing us our y coordinate. If we were at a y coordinate of 100, by going up one block, we will be at a y coordinate of 90. Like we saw before, the ranger would have a y coordinate of 10 at the top of the game screen. We are going up, so our x coordinate will not change. X position and y position are two variables that will hold the current x and y locations of the ranger while the macro is active. To ensure this information is saved after the macro is complete, we will write this information into the chart on the Excel spreadsheet. Here we have the direction the ranger is facing, the current x and y coordinate of the ranger, and the combined location of the ranger using the ranger positioning system. What happens when you walk into a wall? Here is the answer. We are declaring a variable by the name hitWall and assigning it a default value of -1. Here we have an if statement that includes for loops or do loops. The if statement is fairly simple and is determining if we are on the first floor or second floor of the maze, or in terms of the nature shrine, has it been activated. Now let's look closer at this for loop. Cell is a variable that will contain the locations listed in the wall arrays that we looked at previously. The wall arrays use a single number location like the ranger positioning system. There is over 400 wall locations for floor 1. This for loop will look at each of those wall locations and compare it to the ranger's current position. If there is a match, it means that the ranger is currently located in a wall, and we will set the variable hitWall to 1. We will get back to this in a minute. This last part of the code replicates when we move the ranger by copying and pasting the ranger to a new location and a pathway to the ranger's last location. Here we will start by copying and pasting a pathway element to the ranger's last location. You'll notice this will only happen if we didn't hit a wall. Previously, all of our copy and paste commands have used Excel's default alphanumeric address system. This copy and paste command has a special format, so you can enter an x and y coordinate. However, it still targets on the top left corner of the block element. To convert the coordinates from the bottom right of the 10 by 10 block element to the top left, we just need to subtract 9 from each coordinate. So the opposite of not hitting a wall is hitting a wall, or in our case, the ranger is mathematically in a wall. It is a good thing we haven't drawn the ranger yet. So here we are resetting the ranger's current x and y location with the ranger's last location, essentially pushing the ranger out of the wall. Finally, we get to copy and paste the ranger in the correct location. Once again, we're using the ranger's x and y coordinates. The last things to do are update the ranger positioning system and call up the gameplay macro. There are 4 direction macros, up, right, down, and left. By linking them to a common gameplay macro, we only have to code the gameplay commands once. The first 2 if statements contain pop-up messages when the ranger is beside the shrines, so we'll move on. This is the unique if statement in this macro, so let's walk through it. If the ranger is at the secret grove and the nature orb has not been recharged yet, then recharge the nature orb. These 2 commands are changing the color of flowchart connector 1, which is a terrible name. If we right-click on the nature orb, you'll find out that it is actually called flowchart connector 1, mainly because I didn't bother giving it a cool name. Also, if you look at the drop-down box, you'll note this is how we assign macros to objects and how we format objects so they look awesome. And if we go to the Insert tab and look at the list of shapes, you'll note that the nature orb did start as a lowly flowchart connector. To finish off, this last if statement is a congratulations message, and along comes the pixel artwork as a reward for finding your way to the exit. And with that, you now have a much better understanding of how range request was coded using VBA macros in Microsoft Excel. Visit us at our YouTube channel, Minotaur Maze Engine, or our web store at www.minotaurmazeengine.com. Thank you from the Minotaur Maze Engine, the maze where the walls move.